Alright, we have a beautiful positive quadratic. Alright, smiley face. This, however, is the gradient function. Alright, so we're given the gradient function, and it is a positive quadratic. In other words, it's something like an x squared function. Now the question is asking us to sketch the original function. Right, so we're given the derivative. We need to find the antiderivative f of x. So before we start, if we start with a positive quadratic and we anti-differentiate, we will expect a positive cubic. So it goes from a positive quadratic to a positive cubic. So our sketch will be a positive cubic. Now, we can't just go whack it on anywhere we like. There's a few key points we need to look out for. So, from the gradient function, the intercepts, the x-intercepts, so that's at -4 and +2, they have a y value of 0. So that tells me that the gradient at x equals 2 is 0. The gradient of the original function at x equals -4 is 0. So these actually are the turning points. So just to help us with our sketch, at 2 I'll put in a dashed line, and at -4. So I know that the turning points must be on these two lines. Cool. I know that the shape is a positive cubic, so it could look like something like that, or it could look like that. Right, as long as the turning points, oh, that was a bit off, but as long as the turning points are in line with those dashed lines, we're on the right track. So maybe we could put in our dots first. So put in, I don't know, here and here. Those are my two turning points, and I connect them with a smooth curve, like so. Now, can we be more precise than that? If you wanted to be very precise, you could actually find the equation of this quadratic, anti-differentiate it. However, you wouldn't have a point, so you won't be able to find C. So, yep, this is good enough for us. That would be in, well, a merit actually for this one. So if you got the correct turning points, that would be achieved. But if it was a positive cubic and the turning points were clearly at x equals 2 and -4, that would be a merit. Alright, and I guess while we're here, final thing is just to check, does it make sense? So at -4 and 2, we'd expect the original graph to have turning points, right, a gradient of 0. Between them, the gradient function is negative, which means the gradient of the original function is negative, it's decreasing, so that lines up. And then outside of that, the gradient function has a positive value, which tells us that the gradient should be positive, which it is. Alright, pat on the backs all round.